Kannst dein Telefon muten, bitte?
Good morning and welcome to today's opening session. We are glad to have you here. We have got a super duper panel lined up for this first session. Now, a couple of quick housekeeping things. This session is being recorded and it will be available on demand in about 2 days. You'll get an email letting you know when that's available. And also, and this is way beyond housekeeping, I want to be thankful for the sponsors we have. Without them, today's sessions would not be possible. A very special thank you to Eurotech and to WellAware for sponsoring this first panel discussion. Now, towards the end of this session, which will end at 9:25, so you have time to prepare for the next one, we will be taking questions and addressing those. And I will be picking those questions up out of the Q&A tab, not the chat tab. So you're free to chat. You can say hello to your friends. You can talk about how great this is. You can tell us where you are. You can do whatever you want in chat because I will be ignoring that. I will be looking at the Q&A tab for questions near the end. And we will have you out in time to get ready for the next session. Now, before we start into the content, we want to know a little bit about who you are. So Lucian, if you could put up poll number 1. Audience, I'm going to ask you to answer these questions. It's one question and just pick the answer that best fits so that we kind of know how to target our responses. Lucian, I cannot see the poll.
You may have to move on and look. It appears that I have a different poll load up. So I have the IoT and Edge, so apologize.
Okay. That's okay. This first poll question was designed to find out where you guys are in the spectrum from, less than my 90-year-old mother to where this is all about you. Yeah, that's a different, there we go. Okay. If you could all take that poll question real quickly, then we'll know where to start.
Right, so we have about 70% of people taking that. Gonna display the results. There we go.
Okay, that helps us a lot. So we've got, what is that? About 70% are in the early stages. And then a very limited number have widely implemented edge computing and industrial analytics. So thank you for taking that minute to do that. That helps us respond more effectively to our audience. So I appreciate that, Lucian. I'm now going to introduce the panel real quickly. I'll start with XaaS Desai, who's located just outside of New York City. He is the president of WellAware, which is one of the sponsors of the full day and specifically of this session. They are a full stack industrial IoT company serving energy, infrastructure, and air management markets. XaaS is responsible for all operations of the business. That means he's a bigwig. With 2 prior successful exits of high growth technology companies, that means he's a rich bigwig. We like that. He brings experience in scalability and change. His early career began in steel, mining, and heavy engineering businesses of the Tata Group, followed by roles at IBM and Dun & Bradstreet. Next, my friend Patricia in Germany. She is the CEO of a startup hub and vast management experience across all kinds of industries, focusing on analytics and digital transformation. Successful track record in diverse geographic spaces scattered throughout Europe and the Middle East. And at the same time, she's a former academic with a PhD, but she's not a theoretical academic. She's a real practical, well-informed PhD. Next, we have Marcia Gabois of Austin, Texas. I'll let you figure out the French pronunciation from Austin, Texas, but she's got an interesting life. She's currently the president and general manager of Adisra, that's A-D-I-S-R-A. She's an entrepreneur who's grown a startup from inception to a successful liquidity event. She's held a variety of high-tech senior management positions from business development to strategy and competitive intelligence. She has more than 34 years experience in diverse technology areas ranging from artificial intelligence to operating systems to rapid application development and industrial automation. And in her spare time, she has contributed to the writing of a book, Client Server Programming with RPC and DCE. You got to be an acronym person to even know what that is, as well as the author of many other articles that she's written and other white papers. Our 4th panelist is Lionel Liel. Leo is Director, Global Advanced Manufacturing Engineering at Whirlpool. He has over 15 years experience across automotive, electric vehicle startups, and advanced consumer products. He drives strategy for industrial digital transformation across the global Whirlpool organization with a focus on connected product and process development. Latest manufacturing technology implementations are focused on building a foundation in data architecture that can deliver production intelligence for the application of concurrent engineering methodology. And lastly, I'm Becky Morgan, your moderator. I'm in Cleveland, Ohio. I had 14 years in operations for corporate entities before starting my consulting business 31 years ago. I work with leaders of closely held manufacturing companies in the $100 million to $1 billion range to build operational capabilities that provide competitive advantage in alignment with the business strategy. My latest book, Manufacturing Mastery, The Path to Building Successful and Enduring Manufacturing Businesses, is scheduled by the publisher for a late summer release. So that's us. We know a lot of stuff between us, and what we don't know, we won't pretend to know. So don't worry about that. And panelists, I probably butchered your name, so feel free to restate your name correctly when you answer the first question. Now, Marcia, I'd like to start with you. And I want to start with a basic question which fits this audience well. They say if I can't explain it to my mother, I don't truly understand it. So could you help us understand what is edge computing and how is it different from other computing? And then how is industrial analytics different from any other analytics that a manufacturing company would be doing?
Okay, thank you, Becky. First of all, my name is Marcia Gabois, and I am the president of Adisra. Edge computing is a distributed computing paradigm that brings the computational and data storage closer to the assets. According to Gartner, by 2025, 75% of the data will be processed outside of the traditional data center or cloud. And according to Grandview Research forecast, the global edge market will have a compound annual growth rate exceeding 37% from 2020 to 2027, reaching $43.4 billion by 2027. There are many advantages to using edge computing. in your digital transformation, such as faster insight, closer to the asset, improved response, and better bandwidth. Also, with COVID-19, it has become even more important to be able to have remote access closer to your assets. So that's why it's becoming a huge priority in today's new transformation of the workforce. Last, you asked about edge analytics, which offers a lot of advantages. Edge analytics has similar capabilities to regular analytics, except that it's done on the edge or the asset, closer to the asset. At Adirsa, we are seeing real customer applications and value in edge analytics. So it's becoming very popular.
Thank you, Marcia. And
you did ask one other. One other question. Did you ask one other question about the industrial analytics?
Yeah, how it's different from other analytics.
Yeah, sorry, apologize. Edge analytics is simply the process, as I said, of collecting, analyzing, and creating actionable insight in real time directly from the edge or the IIoT device that is generating the data. Edge analytics takes things to the next level, where more data is captured and complex analytics are done before action is taken. So it's sort of nice because if you think about it on the plant floor, a lot of times you want to be able to capture the data quickly and know that you have a quality issue before it happens. A lot of analytics are like machine learning in the form of, or is a form of analytics that is being used a lot today to extract data, learn from it, and forecast the future. So a machine failure, being able to forecast based on historical data, what is going to happen in the future and being able to stop it before it happens.
Okay, so just to clarify for my mother, edge computing is if I need a decision, I need data in immediate. I don't want to take time to get to the cloud and back. That's correct. When edge computing helps.
One of the best examples that always stays in my mind, and it's very simplistic, is you think about these self-driving cars, right? That's an edge device. The car is an edge device. I want that edge device to know to stop at that red light or stop before it hits the car, not to go to the cloud to figure it out, because by that time I've already hit the car or I went through the red light. That's a good example. That's a very simplistic to understand, right?
Thank you. And that's what my mother needs. So thank you very much.
You're welcome.
Shayars, I want to move along to you. We all talk about big data and how it's going to be the solution to everything. And yet most of us can't control the quality of our small data. You know, we don't even want to use it to make decisions because we don't trust it. So what does data quality truly mean for a manufacturer in edge? And is that any different from the data quality requirements that companies have in general?
Okay, so this is Shash Desai. Thanks, Becky. It's great to be with this audience. Thanks to the IoT world for inviting us to this event. In response to the question, we think about data in really two parts. The first part is data quality as a business model. And what that entails is sort of the mastery of the full stack all the way from the field, as Marcia described it, all the way to the cloud. And so whether you're an external vendor or an internal division, the quality of the data needs to be governed by what we call a service level agreement, an SLA, very much like a managed service provider. And what you're doing is you're governing the data on behalf of an operator. From our perspective and my perspective, having spent the better part of my life in technology, it's no different than the back in the time when we owned servers and all the maintenance around a server. And the arrival of the cloud changed all of that. And it's going to be no different with IIoT and the edge. And this highly optimal model really allows a manufacturer to focus on using the data while the managed service provider, whether internal or external, is turning all the dials to make the data better. In our market, we call that data as a service. That's a kind of a new phrase that we're hearing more and more about. And you're taking accountability really for the hardware, software, and connectivity. But essentially what you're trying to drive are the outcomes. For example, I don't want to over-inject chemical into a tank. And that is a classic example of that's the outcome I want to drive as an IoT partner. The second part is really what is data quality from a framework standpoint. We think about it in really 4 dimensions. One is accuracy. The other is reliability. The third is timeliness, and the fourth is access. And accuracy, can be defined in various ways. Low resolution is just one example where you pull data infrequently on the asset. You're going to miss events, about how that asset is possibly doing. A simple interval like 1 minute or 30-second pulls of data compared to, say, a 5-minute pull or a 30-minute pull could overlook, frankly, a disastrous event. Reliability is really about incomplete data when you think about it. And so you're building redundancy into the asset, you're building redundancy into the IIoT framework. So that could be whether it's a power outage, a network failure, caching ability on the edge, as Marcia described it. You really want the ability to self-sustain. And so you want the data to be clean and complete. And then there's lag, which is, or timeliness, as I called it. And that is mostly around latency of data. You take care of that through computing on the edge, storage on the edge, but really for the most part, you're creating a data hierarchy that ensures the most critical data is rendered out quickly and is transmitted over a high-speed network, or is locally computed to take an action or a control event on the asset. And then the last thing is accessibility. And this is something we're seeing plenty of in our client interactions, which is the ability for different silos in an organization to share data. And for this, you need to be able to standardize the data. You need to have open access to the data. That could be MQTT or API formats. I'm using acronyms here, but really these are open source, open connectivity formats that allow data to flow from one system to another. And a good example of that from our experience is we serve a lot of sectors, including the oil and gas sector, and with several of our customers. We're solving IIoT operational problems, but we're realizing pretty quickly that this very data is very relevant to the sustainability group in those organizations. So from an environmental perspective, we're using the same data set, but driving a very different reporting outcome. So that's really the summary. Hopefully I addressed your question there, Becky.
Yeah, I think you did. I appreciate that. And Patricia, considering what Shairoz just said about quality of data, is real-time data friend or foe?
Hello, everyone. Thank you, Becky, and thank you all for being here. My name is Petruța Tătulescu. Well, considering what Shire said, real-time data has a lot of potential for your business, especially if you have a big manufacturing business. But considering the human factor involved in there and considering the processes that you already have in place, that data might actually turn into a foe or your enemy, because maybe the way your processes are put in place will not allow for that quick data to be implemented as quickly as it must be implemented. And considering the human factor, that might actually lead to a lot of frustration within the core group that is supposed to administer the real process and also to overlook the data. So you have to be very careful when you're implementing very quick data and data that was gathered in real time and data that is moving very fast. Because you really want to make sure the outcome is what you were looking at in the first place.
Okay, thank you. Now, one of the first questions we have in the Q&A, and Patricia, you or Leo, you may want to build this into the next question I have for you, is, okay, we used to have computers in our manufacturing facilities, and then somebody invented the cloud. So now everything's everywhere else. And now it sounds like we're bringing it back to the way we were 10 years ago. So is this really progress, or what's the big change here? Now, Patricia, do you want to address that, or do you want me to go ahead and move on to Leo? Leo, are you happy?
No, sure, I can take that. It's
okay.
It's a very different type of thing from a software and also from a hardware perspective. We're not going back to where we were before cloud. We're not putting up servers in our manufacturing facilities in order to cover that data. It's all still governed basically from the edge or from the cloud at the end of the day. And we are not going a step back, but we are actually going a step further. Whatever you are extracting now from that multitude of data you get in the cloud is the essence, and it's the analytics that is helping you understand that entire bulk of information and disseminate it in order to be able to implement it and make it useful for your needs.
Okay, thank you. I appreciate that clarification because that's a reasonable question. And when we're talking about the speed of response, you know, we're saying that edge computers store data and do calculations, and I think that's what a computer does. So the distinction is an important one for people to understand. And if I understood what your comment, it was that everything is going to the cloud, but very select critical things are at the edge, where that time makes a difference. Did I understand you correctly?
Yes.
Okay, thanks. So Leo, if you'd like to add to that clarification, that would be helpful. And in doing that, what are some low cost, high impact work that teams should focus on when you're looking for an AI or an edge application or business case? So it kind of seems to make sense that the distinction between where we were and where we are now with edge would be integral to defining or knowing a business case.
That's right. First of all, yeah, happy to be here. Thank you for everybody, along with joining with our sponsor and our panelists here. Happy to be part of this great conversation. So I think the first thing, and I'll tie it back a little bit to that question from the audience as well, is when I think of this work and looking at what is the first thing you can do that's low cost again and hopefully drives big impact for you that I've seen, is really sitting down and kind of road mapping your way from where your current problems are and your biggest losses in your industrial space, and really analyzing those losses so that you can do kind of like this old-fashioned defining problem-solving strategy, connecting it down to those elements that you need on edge computing, those analytics you want to get, and those insights that are then going to solve those problems. So I really ask teams to consider that at the beginning. One of the biggest things you can do to drive that impact is really sit down, roadmap your way, understand what purpose you're going to get from that insight and how you're going to drive impact. This also helps prevent issues where you might start with, you know, researching some edge computing technologies and then realize after you've piloted that it doesn't really connect to business impact that you want to drive. So I think for me, that's really the first thing I ask teams to kind of use those tools, favorite brainstorming tools, and kind of visualize your journey and how you want to get there from a problem perspective. And then I think that connects a little bit to the question from the audience as well, because you know, how is it different? It's really an architecture question, how data flows. You know, in the past, yes, you might have servers and computers, and then we went to the cloud, and now it seems like we're going back. But in reality, what we're doing is we're going back to not the old way, but we're going to a new architecture that allows you to use a lot of the latest power of decision making at the asset, right? As opposed to having data flows back and forth. So it's more about thinking of that data architecture and how information flows instead of where the computer necessarily sits. The edge computing actually changes that paradigm a little bit. So now the decision making and the power sits at the asset.
Okay, so I need a specific example so I can understand it. So when we talk about a problem, well, I've got a manufacturing facility with a bunch of equipment in it, and I got problems galore. So could you give an example of a specific problem where edge computing?
Sure.
be?
Yeah, absolutely. I think one of the biggest things people run into, it's been a common problem for a long time, is machine downtime, and we've become better and better at doing that. But now you start seeing, you know, this the power of edge computing. You can actually start analyzing things like micro stoppages and what in the old days maybe you wouldn't consider downtime. It's like transition of work or product changeover leading to time where the equipment is not doing what you think it's doing. The equipment's not generating that value. And once you start collecting that data, then you can start analyzing what's driving those losses specifically. So that problem there of can I get more capacity, or why am I, you know, running overtime, for example, can be stratified into that scenario.
Terrific. That helps a lot. Thank you. Now we've got two more polls that we would like to ask our audience again, and this will, as we move into the second half, we want to kind of know where you are on these things. So Lucian, could you put up the next poll, please?
Roughly about 63% of people took the poll, so less chance.
Okay, so this is consistent with the first poll we took. I'm not surprised. A lot of people are saying they don't have any plans to do this at all at this point, which makes sense. If you're just getting started, this is probably not where you'd start. And again, a big chunk of you are researching, and I think that makes sense as well. So that helps us understand. Thank you. And Lucian, could you go ahead and put up the next poll as well?
Here we go. Give it about 40 seconds for this one. Please take the next survey. Thank you. There you go, Rebecca.
Cool. So we've got a big chunk of people that are giving the impact on the environment and sustainability some thought. That's some pretty advanced thinking, especially when most of us are early into becoming familiar with Edge. So thank you for taking the time to answer those two poll questions. Those two questions were some fairly sophisticated questions from a business perspective about edge computing. They weren't about architecture or software. They were about some significant business issues. Patricia, if we're looking at significant high-level business issues, but I'm a startup, should I begin with edge and industrial analytics? And if I'm a startup, what do I think about scalability? It's not my intention to be a small startup forever. So help me understand where edge and industrial analytics fit into the startup and then scale up plans.
Well, I will turn it around a little bit, Becky. You have a few startups out there that are in manufacturing and they're establishing themselves and they're doing pretty well. But where I see a huge opportunity for startups is actually in the data analytics and in the edge computing. And again, there are a few startups out there establishing themselves. I've been working with startups for quite a while now, and their biggest challenge is actually that big manufacturers don't know them, never heard of them, are not necessarily open to working with them. And these guys, they're really smart kids, and they're really good in the niche that they're doing, and especially with data analytics. And it would be great for the manufacturers if they listened to them and if they worked with them. And when it comes to scalability, that is possibly at the moment one thing to think about, because these kids come with a really good solution and you can implement it in one of your big manufacturing facilities, but is that scalable to 5 or 10 big manufacturing sites? If you are possibly a manufacturer that has those 5 sites, that is indeed a very big question at the moment, and something to be continued, I suppose. I don't have a perfect answer to that right now, and I don't have a crystal ball to tell you how it might look like in 5 years, maybe.
Okay, terrific. So you're talking about who's actually doing the analytics. We're collecting data,
yeah,
but who is doing the analytics? Now, is the analytics a writing software to do the analytics, or is it actually looking at data to do the analytics?
Oh, there are many ways of doing it. A lot of people at this time are trying to use blockchain and artificial intelligence to process that data. I'm sure Marcia would be able to fill up on that a bit more from the technical side. But at the end of the day, what really matters is how do you implement that knowledge that is, in my opinion, served to you. If you're a manufacturer, it's being served on a silver platter. It's just, you have to just grab it. And that's what we are talking about here, is the future of manufacturing. And I think that really, truly is the future. It's possibly not quite there yet, because people are still, having second thoughts, and maybe they've never heard of this one startup or the other startup, or what are those kids doing with my data? There's a lot of data. I suppose people are not sure how that is being processed and what is happening with it, especially in Europe and in parts of the world where data protection is a very, very big issue. So at the moment, it's the technology is there and everything is there. I see it as the future of manufacturing to implement all that is there, and that how do you implement it and make sure it fits into your processes so that you get the most out of it.
Yeah, there are a lot of surrounding issues on this. And when you talk about the data, it's who owns the data, who can do what with the data. Those are big questions. Marcia, maybe you can help us here. What's a good example of using analytics on the edge? And then if you can think of one, can you share one that failed completely and help us understand where the failure was? Was it technical? Was it business case? Was it logic? What was it?
Okay. I'm going to point out, I agree with a lot that my panelists have said. And really, when you start to look at edge analytics, you really have to think about where do you want the analysis of the data to be done. So as an example, as you asked, if you're an offshore oil rig, which has hundreds of sensors collecting data, but you're miles away from a data center or a cloud, you really want to, if there's a faulty switch or that the analysis be done closer to that asset on the rig so that you could shut off the valve before an accident happened. That's an example of. Another one might be like when you're in the plant floor and you're actually doing quality, you want to do predictive analytics closer to where the actual asset is collecting the data in real time with machine learning and be able to alarm someone if there is an issue before it actually happens, right? So you don't waste a lot of time. So you wanted to know where I saw some failures. I think a lot of the failures are one in what Lionel pointed out, that they didn't look at the whole business case and where the analysis should be done, right? I mean, a lot of people jumped in and said, oh, let's send everything to the cloud. Let's now put everything on the edge. Let's get into machine learning. Really what you have to look at is the complete picture of where do you want the decisions to be made. And when I see failures, I see a lot in stuff like people not thinking through the security, because cloud security is defined by the cloud that you're sending it up, but edge, all these edge devices are also entries into your system, right? And you want to make sure that they are as secure as any other part of your architecture. So I see a lot of people not thinking through some of these pitfalls. Like another one is if you're going to do a lot of edge, you're collecting the data and you're making the analysis at the edge device, you still want to send it to a cloud or a data center or somewhere to have the raw data, because you want to be able to maintain that model. So if you see something going wrong, like some models are outdated, right? And you don't want to make bad decisions. So having the raw data to collect, to still be able to do the analysis on the data center or in the cloud is still important, because you want to keep all these edge devices up to date. I'm sure, now back to your grandmother, I'm sure that everyone gets their smart watches, their smartphones, all these devices that are also edge and sensors, collecting data, sending it to a cloud, have to be updated, right? They don't, I get this all the time. It seems like at the worst time possible, they want to update that device. It's the same thing on manufacturing. It's a smart device, right? It's a sensor that's collecting the data, and it too needs to be kept up to date because you want to make good decisions.
Thanks, Marcia. That's helpful. This is complicated stuff. There's a lot to think through. Leo, just to complicate it a bit more, how do we connect data, edge computing, and analytics to improve our supply chain? I mean, we've just seen a supply chain nightmare around the world. How do we use this to have a more resilient supply chain?
Yeah, exactly. You hit the nail on the head there. So we have supply chains that are disconnected, that are being disrupted from numerous, factors, right, over the last 12 months, and it's in some cases continuing to be ongoing. So one of the things that a lot of people have talked about since then is how do we make our supply chains more robust? Maybe it's about location or how we source and all these other kind of quick fix solutions. But I think it's more about the inputs and outputs and connecting those correctly. So thinking about your operations or your manufacturing site, for example, and starting there, and then thinking about a little bit, okay, if I have edge computing and analytics that I can understand kind of my ordering process of raw material, I can understand my incoming, predict my incoming sequence of raw material, and then connect to my consumption down to where I'm having yield losses to then connect back to my systems of ordering. I can then start analyzing and making better models on what I need to have in stock and what I need to order and when I need to ship things. And so this also connects a lot to when you're doing things like a new product launch. We had a pretty unique example during the beginning of the COVID crisis where we had a team here that was tasked to develop something completely from scratch related to supporting our healthcare frontline workers. And we were able to develop, in a matter of weeks, a powered air respirator that we were able to donate. And we did that, again, doing a lot of digital tools and having to map back quickly, where's all these sources of raw material that we can get? When is it coming? How are we going to staff up our quick line, assembly line to put it together? And building in quick systems that we could then analyze, how we were producing at every station, for example, to give us a better ability to react to what the demand we thought we would get. So I think it goes back to understanding those inputs and the outputs that impact your supply chain. You can never predict the next, black swan event or major crisis, but you could have systems in place that will help you predict where you have those bottlenecks in your supply chain.
And that's got incredible value. Anything we can do to reduce the bullwhip effect would be helpful to all companies, because this on-off switch of 0 to 100 is not effective for anybody. So I think what you're talking about is very important. Thank you, Leo. Sharif, our poll results said that people do are thinking about and are researching how all this can help us with sustainability. So you have some expertise there. Can you help us understand how this edge computing industrial analytics can help us improve our sustainability?
Sure. I thought the results were fascinating, actually, from the poll. The fact that 75% of the audience felt like it was still actively researching and exploring the concept and thinking about it. But sustainability, as we see it, certainly defined by environmental, social, and the governance factors, is going to have a profound effect on IIoT. Today this is commonly characterized as ESG. It's getting very popular on Wall Street. There's been a massive influx of funds that are purposed behind this topic. Certainly over the last 2 years, I mean, we're talking several 100% growth rate. So we're feeling that our customers, our clients are pushing more and more towards, well, you have the data, you have this, you have the operational efficiency data. How do we now translate that into, sustainability reporting? And the fact is that these are not mutually exclusive. So they're almost never mutually exclusive. You're driving an efficiency project, you're having some impact on some aspect of the ESG conundrum. And so we call this hidden data, or hidden value in the data. And one thing we've learned is several of our customers, the greatest challenge is not really the reporting software, or that they don't have people in the sustainability function to go collect the information. The issue is really getting good quality data from harsh hazardous environments, from challenging environments, from the edge, and getting it into a format that's usable. A lot of the time we're seeing an opportunity to complement an existing data system. So for example, a SCADA system or a DCS system, but you're overlaying it with an IoT footprint. So in terms of a solution, we're pushing customers in two different dimensions. One is you got to have a sustainability policy, and there's a lot of great organizations that support that. And then you've got to have a data governance model that is doing three things. One, you've got to measure the impact to the environment or the safety conditions. You have to achieve the outcomes, and so you've got to measure what the achievement rates are. And then you've got to report against that. So for us, it's things like, I think a lot of us, Leo just described a few events. Marcia did the same thing. We're measuring truck rolls and incidents and spillage and, zero emissions, for example. These are things that we're getting to really deploy and read. And the more we get into the field, the more we are analyzing, we're coming to recognize the importance of data analysts, data scientists, whose experience, certainly in environmental management, is really critical to any IIoT initiative. So it's sort of bringing in a new discipline and a new field into our realm, or kind of our window of operation. The best example is we think of the Project Astro, which is an effort from a bunch of operators in Texas, alongside a couple of research institutions that have created a field network of sensors to measure methane emissions. And what's great about that is, at the very least, you're going to be able to predict a leak from a pipe or from a facility or production facility. But more importantly, when you produce gas dispersion models, it's able to predict the movement of the gas or the leakage and the affected areas, something that we don't have easy read into these days. So IIoT has gone beyond just sort of the core operational aspects to actually protecting and sustaining companies, and doing that very profitably. So, we like to say that ESG and financial profitability are actually the same thing. It's just a matter of a better accountability and eliminating redundancy.
Terrific, thanks. So the oil and gas companies don't need turkey vultures anymore to tell them if there's a gas leak. We're moving forward.
Yep.
Okay, thanks. I'm going to move to some audience questions now. Anybody, just tell me if you're ready to do the answer. Rick asks us, how will 5G rollout impact edge computing?
I mean, 5G just really does allow faster bandwidth, right, to collect the data quicker, right? It also has a lot more security built in. So it does have a better security towards the edge device. So that's how we're viewing 5G.
Okay, thanks. And I think of 5G as more bandwidth and faster. And I think of edge computing is using your bandwidth more effectively and faster. So to me, they would seem to be hand in glove, but as a non-technical person, you know, I can't say that's true. It just seems to me. Okay, here is a question from Juan, and this is not for me, I can assure you. How important is application architecture in designing edge solutions? In particular, thinking of legacy plant systems and how we change the thinking of the teams who manage those currently. One of you want to take that architecture question?
Yeah, I'll take that, Becky. I'll take that question. I think you know, I'll take the non-technical aspect of it, or at least the semi-technical. You know, from my perspective, it's critical that you know, the IIoT venture needs to look at the data being analyzed, or what problem are we trying to solve, what outcome are we trying to drive, and you know, in our experience, creating a data framework where the IIoT data complements and is integrated with the probably what is being described here in the question, a legacy operational environment, to create a unique single view of the data is really critical. I think this requires a lot of sort of bringing together of sort of a group of operators who probably had a hand in the design and build of the original system, people in the business who are looking for a different outcome. So, for example, they might be seeking you know, an increased amount of resolution in the data. We need to see data that is at a higher frequency, and let's say the current SCADA system is not polling as frequently. So really what you're doing is you're putting sensors down at certain points in the production process, whether it's on, you know, we see this a lot, for example, in compressors, where you'd put it down at certain input output points. You'd look at things that are almost extraneous to the core production process. And now you're assimilating all of that into a more holistic view of the manufacturing facility and all the inputs, outputs that are impacting the asset that you were traditionally measuring against in, you know, in a more traditional architecture sense. Love for others on the panel to, you know, contribute to that as well, if it makes sense.
Well, and building on what you just said, and I don't know what a SCADA system is, but there's a question, I heard you say that, and this says, how does edge computation differ from SCADA systems? So I want to, if somebody can address that.
Yeah, I'll take that, since I have done SCADA HMI for the last 20 years. SCADA is, okay, it's very much a part of the whole solution, but I view SCADA, and you know, my current company does SCADA and HMI still, as well as analytics and stuff. SCADA is really looking at the, as I like to say, the rear view mirror. You're collecting the data, you're viewing it as what has happened in the past to figure out how to fix whatever the process is in the future, right? Analytics is now saying, okay, let's look to the future. We've got all this data. We know how the system functions, and we can start to predict when something is going out of control, right? So it's still, SCADA plays a role. I believe it really does. And both HMI and SCADA play a role. And they play a role as letting you know what is happening. And a lot of SCADA and HMI systems are now starting to incorporate analytics to do machine learning, to see the future as well. So that's how I see the difference. And SCADA is just supervised control and data acquisition, just for,
okay.
That's the acronym.
Okay, thank you. We've got a lot more questions here, but not a lot more time. Several of the questions are about control of data, IP of data. all around the ownership, the use, the security. And one of the questions specifically was about the IP that's in the data. So what I want our audience to realize is that Lucian will be sending our panelists these questions afterwards, and we'll have a chance to give responses to those. And then Lucian will be distributing those. So I wish we could have gotten to all of these questions because they're great ones, but we just can't do it. So you will be getting those questions addressed, just not right now, because we do need to move on at this point. And we have shared a lot of information here. And I think, you know, if you turned on here to find out what edge computing is, you may be feeling some overwhelm right now, because there's a lot to it, obviously, technical, business, etc. So what I want each one of our panelists to do is just summarize what's the one thing that you want the attendees to take away from today's conversation. So Marcia, would you start? What if I'm only going to remember one thing from what we've talked about, what should it be?
Well, I just want to say that really, whether you're using, you currently have a proprietary HMI SCADAs, you have a lot of data there. They all play a role as you move from the digital transformation into the edge with the analytics. It's all part of collecting the data and really driving organizations to better data-driven decisions based on all the data, whether it's remote location, and viewing it remotely, viewing it locally. They all play a role together. And that's what I want you to remember.
Thank you. Thank you, Marcia. Leo, what do you think they should remember?
Correct. I think the thing I would say to take away is, you know, edge computing is about democratizing the data and empowering people at the front line or even at the, you know, middle management layer to understand what they can do and how they can solve their business problems. So for me, the biggest thing to remember is focus on those problems. Think about the data that is actionable for the people at the asset, and focus your energy and edge computing strategy there.
Okay, thanks. And I'm going to sneak in a follow-up question from the audience on that, Leo. One person asked if predictive maintenance and using sensors for vibrations and those kinds of things, is that a common example of what you just said in your closing comment? Think about how data can help somebody right there make decisions using that.
Absolutely. Yeah, once you have that, you know, sensor suite, IIoT, and you're at the source, and then you can start making those connections. You're solving that time, right? Not just the time to problem solve, but predicting and modeling out what could happen in the future.
Terrific. Thank you. Patricia, what should we remember?
Also building up on what Leo has just said, if you are a manufacturer, you really might want to consider working with startups, because Leo was saying, well, you really need to consider all those problems and issues and whatever might be out there. Well, work with these new guys on the block, and you might not have to think of that, because they will think of it, and they will come up with solutions for the problems you didn't know you had. They might actually save you seven digit, sorry, they might save you a lot of money. You know, we are talking about 7 digits here, and they might have a proposal in a niche area that you never considered, and it's just one small little thing you think, and at the end of the day, if you're open to working with them, if you're open to new solutions that they might bring, that might actually save you a lot of headache and a lot of money.
Thanks. And to follow up quickly, you're thinking bring them in to help us identify business cases that we may not have thought of.
Absolutely. Absolutely. If you look at it from a consulting perspective, yes, they might come in and analyze it properly and bring in a very new perspective and fresh air, basically. or if they already have, they developed some niche app or solution or something that they already have, be it a software or a hardware solution, just if you are a manufacturer, just be open to at least have a look at it. And you never know what that might bring to you. At the end of the day, okay, maybe you wasted an hour by looking at it, and that's it. But what if that is the exact thing that will save you 7-figure amounts of money?
Terrific. Thank you. Thank you. And Shaharsh, what do you think we should remember from today?
So I'd say, you know, as the cost of compute drops and the cost of connectivity drops, which is inevitable, the edge is going to generate a huge amount of data, a lot of high quality data at very low prices. And I think our biggest challenge, frankly, is there's going to be a lot of data. The question becomes, how do we as organizations change our cultures and our processes to adapt to the new data in the new way? One recommendation I'd have, just in my experience, in our experience with some of the largest transformations out there, you have to assemble a cross-functional team of financial analysts, data scientists, organizational change managers, and data services partners who really bring a new set of skills to the industry and complement what already exists, outside, but needs to be brought in. And the final thing, the real key catalyst to all of that is having an organizational champion who has the ability to bring those resources together and socialize the concept up and down the organization. Because in my view, if the CEO and the CXOs of the company haven't fully bought in and haven't really done the sort of due diligence around what it's going to take and what it really entails, these ventures tend to stay in very pilot mode and don't really take off into full commercial scale. So I'm hoping that the next 5 and 10 years is a realization for all organizations to come to this new form and this new movement, so to speak.
Yeah, and that's given that people don't like math, talking about all this data can just scare the heck out of the average employee. So I think your point is a very valid one. This isn't just bring in and analytics is going to save our world. It doesn't. It can, but it can also do bad things. So we need to be very careful of what we collect and how we manage it and what kind of decisions we use. That brings us to the end of this first session. I want to thank our panelists. They have brought some great information, and I'm going to call my mom and make sure that she understands all this. I can even tell her what SCADA is now, so that's good. Thank you, and thank you attendees for the great questions you've asked. As I mentioned, we will be sent those questions by Lucian and we'll answer them, and then his team will get them out to you. And I want to have a big thank you to IIoT World for bringing all of these insights to those of us who love manufacturing. There is a lot going on. It's hard to keep track of all of it. So the things that IIoT World is doing to help us introduce and then get more technical understanding and business understanding are just invaluable to us as manufacturers. So thank you everyone very much. And you can get ready for your next session now. Thank you.
Thank you.
Thank you.
Thank you.
Thank you all. Bye-bye.